1943, the Tiger I was the most feared machine on the planet. With 100 millimeters of frontal armor and the legendary 88 millimeter KWK-36 gun, it was a rolling fortress. Allied tankers were told to retreat on sight, but while the armor was impenetrable, the machine was rotting from the inside out. The Tiger I was a 54-ton masterpiece of engineering. On paper, it was invincible, but in the field, its greatest enemy wasn't a Soviet shell. It was its own gearbox. To move 54,000 kilograms of Krupp steel, the Tiger used the Maybach HL230 engine, producing 700 horsepower. But getting that power to the tracks required the Maybach Ulver OG transmission. It was a pre-selector gearbox, highly advanced, but mechanically fragile. The fundamental failure of the Tiger wasn't bad math, it was mass creep. The Henschel design started in the 30-ton class, but by the time Hitler's engineers finished adding invincible armor and a massive turret, the weight ballooned to 54 metric tons. Here is the problem. The engine and transmission were never upscaled to match. In engineering, when you increase mass without increasing the capacity of your drivetrain, you are playing a dangerous game with torque multiplication. The Tiger was a rear-engine, front-wheel drive machine. This required a massive drive shaft running through the crew compartment into a complex, pre-selector gearbox. This gearbox used a vacuum-operated system to shift gears, an incredible feat of precision, but a nightmare for durability. It was designed for the tolerances of a watch, but forced to handle the weight of a house. When this 54-ton beast encountered the deep mud of the Eastern Front, the physics became impossible. To turn a tank, one track must stop or slow down, while the other accelerates. This creates immense lateral resistance. As the driver engaged a turn, the gears in the final drive were hit with peak shear stress. Because these gears were case-hardened, meaning they were made very hard on the outside but brittle throughout, they lacked toughness. Instead of bending slightly under load, the gear teeth would undergo brittle fracture. Imagine a 1,000 horsepower engine pushing against a gear tooth that is physically too small to handle the load. The tooth shears off, a single piece of steel the size of your thumb snaps, and the invincible Tiger becomes a stationary pillbox. But the true engineering sin was the serviceability. In modern design, we use design for maintenance, DFM. If a part is likely to fail, you make it easy to reach. The Germans did the opposite. To replace a shattered transmission, you couldn't just slide it out. Because of the interleaved road wheels and the hull design, you had to lift the entire 11-ton turret off the tank with a specialized crane. If your transmission snapped in the mud and you didn't have a 16-ton crane nearby, you had to blow up your own tank to keep it out of enemy hands. The Tiger wasn't a bad tank, it was a bad system-level design. Germany optimized for firepower and armor, but ignored durability, manufacturability, and logistics. The Tiger teaches us a timeless engineering lesson. A system is only as strong as its weakest component. If you enjoyed this engineering breakdown, like, subscribe, and we'll see you in the next one.